So good evening, ladies and gentlemen. I'm hoping that people in the audience can get a chance to see a couple of people on the panel here. So my name is Garret O'Donnell. I'm an associate professor here in mechanical manufacturing and biomedical engineering in Trinity College. And I'm very pleased to welcome you here to this online event. It's an evening with Garret Lyons, which was really inspired by Gary's latest book, that we recognize we should share some of that insight and also some insight into the man himself. So together with my colleague, Kevin Kelly, and a number of different guests, we're hoping to extract some of Gary's wisdom and personality that you'll remember from those former times. So maybe just a little bit of housekeeping. We're all used now, I guess, to the online environment, but maybe just a little bit of housekeeping. So we are suggesting that we plan to have a short video of the highlights of the meeting. So the meeting is being recorded. That's one thing you should just bear in mind. Secondly, we have the captions enabled there. And if that's something that you don't need or you find distracting, you can turn that off on your Zoom environment. If you go to the menu bar and you see live transcript CC, you can enable or disable that as you wish. We're asking everybody to keep their video on and their microphones off for the moment. And that way everybody can get a chance to see everybody else. And hopefully then later on, we're going to have an opportunity to mingle. So we have the chat function enabled, so you will be able to reach out to some of your colleagues, our former colleagues. And then towards the end of the formal part, we're going to have a series of breakout rooms. Again, I'll introduce you to that at the right time, but that you'll be able to go to effectively a room with your peers from your era. And enjoy a conversation then. In that case, it won't be recorded. So you'll be free to catch up and sit and to speak as you wish. Okay, so with that part of the housekeeping done, maybe I'll just give you a little bit of insight into the way the event should roll out here. So we're very privileged to have the provost who will give a brief introduction as a colleague and longstanding colleague of Garry. Then we're going to go to my colleague, Kevin, who's going to extract some of this wisdom from Garry in a so-called online fireside chat. So it's an environmental fireplace, I guess, that we have this time. So an opportunity to have a nice chat and discussion between Kevin and Garry. And then we had a number of colleagues who wanted to make a contribution to the conversation here tonight, and we'll include those in that. And then we'll move then into the breakout rooms, where you guys get a chance to talk to each other and also to meet some of the other colleagues that you would have in the past. Okay, so it's then my pleasure then to invite the provost, Dr. Patrick Pendergast, to give the welcome and the introduction. So, provost.
Well, thank you. Thank you, Garret, and good evening, everyone. And it's a real pleasure to be here with so many engineering colleagues and alumni celebrating Garry and reflecting on 60 years of engineering in Trinity College. Next year, 2022, will be the 180th anniversary of the foundation of the School of Engineering. This evening, we're reflecting on 60 years of this 180, a third of the entire period of the school's existence, because that's how long Garry has been contributing to the school. This is his diamond jubilee in that sense. And the question, of course, is how anyone can be associated with a university for 6 decades. Well, Garry has notched up that length of service because he began working for Trinity aged 15 as a trainee technician. And over the next 27 years, he advanced to technician, senior technician, chief technician, before he completed his master's in 1986 and began lecturing in mechanical and manufacturing engineering. and he was then promoted to senior lecturer. And that's when I encountered him, when I was an undergraduate here in the mid-1980s. Afterwards, when I joined the department myself as a lecturer in the 1990s, Garry was a colleague. He's now a retired or semi-retired member of the staff of Trinity, holding the position of adjunct professor in mechanical manufacturing and biomedical engineering. In the course of his long career, Garry has received many honours and distinctions, including Fellowship of the Royal Society of Arts, Manufacturers and Commerce, and a fellow of the Royal Academy of Medicine in Ireland. And he has written extensively on the properties of liquids, on engineering design, on bioengineering, and on the history of technology. And he was honoured with a Festschrift by his colleagues in 2008. Anyone who knows Garry, who was taught by him, values hugely his intelligence, his enthusiasm, and his wit, as well as his wide range of interests. It wasn't a surprise to me when in 2015 he published his brilliantly titled book, Steaming to Kingstown and Sucking Up to Dalkey, which described the early days of rail in South County Dublin. And this book doesn't shy away from the technical aspects, but yet it is accessible to the lay reader. And now he's publishing another book which extends his scope, titled Ireland's 19th Century Exhibitions of Industry and Arts, A Tale of Two Cities. And it deals with Irish exhibitions in industry and arts in Dublin and in Cork between 1852 and 1907. This book is a work of social and industrial history. It's full of wonderful research on manufacturing and artisanship. And in its introduction, Garry acknowledges that the 19th century, and we engineers, of course, we don't know much necessarily or study a lot of history, certainly not as part of the formal curriculum. But the 19th century was a terrible time, beginning with the Act of Union, then the famine, and then mass immigration. A terrible century in so many ways for Ireland, but Garry writes that the aim is to show us at our best and display our ability to do great things to help improve economic and social conditions. That's Garry all over, focusing on the positive, and that's why he focuses on the exhibitions, the industrial exhibitions. Garry has found what is progressive and affirmative and forward-thinking. As we know, Ireland did emerge from the horrors of the 19th century, and it was the artisans, the manufacturers, and the engineers whom Garry showcases that helped Ireland to do this. Before I hand back to Garret, I'd like, in the spirit of progressiveness of Garry's books, to fill you in very briefly on what's going on in engineering in Trinity College. We're in a period of really eventful expansion. As I hope you've heard, the construction of the E3 Learning Foundry is now underway on the east end of the campus, and it will open for the academic year 2023-24. The E3 Learning Foundry is changing the way we educate engineers, natural scientists, and computer scientists. Partly in response to all we've done to profile engineering, CAO applications for new courses in engineering are up by 44% and by 56% in computer science. And this is not just some incremental change. Every year they go up and down a little bit, maybe 5% here, up and 5% down. But these are major increases in the number of applications that we have for engineering and computer science in Trinity. E3-based researchers have won 2 of the 4 ERC, the European Research Council funds, very large grants, and there have been 4 in Ireland in the last round, and 2 of those are in E3. Kinsella challenge-based E3 multidisciplinary projects awards worth €500,000 each will be awarded, 3 of them will be awarded later this month. And just last week, we launched the Ryanair Sustainable Aviation Research Centre with a €1.5 million philanthropic donation to mechanical engineering and to physics. And finally, plans for the Trinity East campus are progressing with an innovation hub recently named The Portal, and it's due to open in early 2022. And the E3 Research Institute, which complements the E3 Learning Foundry, is under development as the first new project on the Trinity East campus at Grand Canal Dock. And of course, 2 weeks ago, the college elected its second engineer and first woman as provost, Professor Linda Doyle, who will come into office in August, in this August coming. So it's not an exaggeration to say that E3 constitutes perhaps the most significant expansion in the School of Engineering since its foundation. And it's not just a strategic expansion for engineering, it's a strategic expansion for the whole university. E3 has been enabled through philanthropy, and it's right to single out Martin Nocton and Eric Kinsella for their outstanding benefactions. Martin Nocton for the E3 Learning Foundry and Eric Kinsella for the E3 Challenge-Based Research Awards. But so many others, alumni and friends, have supported E3 and are supporting the next generation of engineers through mentoring, hosting work placements, and supporting scholarships and student services. And we hope to make some additional announcements regarding this in the coming weeks. The School of Engineering counts on exceptionally supportive alumni, and this makes a huge difference to our students. During the pandemic and the lockdown, the support for the Student Hardship Fund was outstanding. Garry is offering part of the royalties from his upcoming book to the Student Hardship Fund, and that says so much about his priorities and his generosity. It isn't the official launch of the book today, but may I take this opportunity to urge you all to buy it as soon as it's released. Anyone with an interest in history, manufacturing, artisanship, or the world fairs and exhibitions will want to read it. And now I will hand back to Garret and Kevin. Let me just say on a final note, as I'm in the last few months of my provostship, I'd like to say to Garry, on behalf of the School of Engineering and the whole university, our great thanks for your contribution to the college. Your trajectory from trainee, technician to professor and author via generations of grateful students is truly inspirational. Thank you.
Thank you, Provost.
Thank you very much, Provost. Maybe we'll proceed into the main event of the evening then, Garry, and begin our fireside chat. So 60 years of association with Trinity, we have a lot to talk about, but given that time span and the context that the Provost has said already of 180 or so years of history, I'd like to indulge in one of your many areas of interest, which is the history of engineering in Trinity. Could you give us a little bit of background about how engineering began in Trinity and where it evolved from? So it started about 120 years before you arrived. Is that right?
Yes, indeed. Yes. In 1841, the School of Engineering opened, and this was due to the hard work of Humphrey Lloyd, Thomas Luby, and others who decided that Trinity must have engineering. And it was very much Lloyd's decision also that engineering would follow the French scientific system. And he looked to the École Polytechnique to gain guidance for how it should operate. And that this would be very different than the English system, which was primarily apprenticeship rather than academic study, although 3 universities had actually started supposedly engineering before Trinity did. Their efforts were rather tentative, and some failed, and some didn't become anything like a reality until about 1855. So we started then with the 2-year course, giving a diploma in engineering. There were 15 entrants put to it, but only 2 graduated with the diploma. Why, nobody quite knows. The subjects were quite fairly narrow, but they did include some little aspects of mechanical engineering, even though it was an avowedly civil course. Heat and the steam engine was present. Then the course was expanded to a third-year course in 1845. And in 1860, then the next big change came with the license in civil engineering, and also the Master in Civil Engineering, MAI. And big change then, minor changes occurred in, I should say, in the teaching of a little more mechanical engineering. And it remained then as a three-year course until quite later. But in 1872, the next significant occurrence was the awarding then of the Bachelor in Engineering, the Bachelor in the Art of Engineering, the AI that we all know. And this was consequent upon the students having gained a BA, but this is a complex reality and not for discussion here. The next—
Come in there, Garry, maybe, and just, you know, there's quite a rapid period of change there. So 1841 was when the school was first founded, but
Yes.
Already by 1846, there's a significant evolution from 2 years to 3 years.
Yes.
And then we had the awarding of a degree or licentiate in 1860. There's a related element there in 1857, which was pretty significant in the School of Engineering. Could you tell us about that?
1857?
In terms of infrastructure to support the work of the School of Engineering.
Well, of course, yes. What I left out completely was that all the work of the engineering school up to 1857 took place in East Theatre and in a temporary building which was created as a drawing office on the site of the 1937 reading room. And then, of course, the lovely museum building, or engineering school as it was called then, designed by Dean and Woodward, was opened, and so the engineering moved to it.
So parallels in some way with now, I suppose, a period of significant change in the school, and facilitated and driven to some extent by new capital infrastructure to allow for that education.
Yes, indeed, significant money was needed and was found for that building.
So can you take us forward then from the latter part of the 19th century and then into 20th century of engineering?
Sticking with buildings then, I suppose the next dramatic thing that occurred was in 1903, what was called the Mechanical Engineering Workshops opened. This was on the north side of the rugby pitch, and remains there to this day, obviously. And with it came also an increase in the teaching of mechanical engineering subjects due to a person called Walter Lilly, and another person called Tatlow began to teach electrical subjects. And there was a lot of pleading for monies to get the right equipment in this building in order that they could expand this area. And it went on and went slowly. And then I suppose the next big change was that in 1956, then the fourth year was added to the course. And with the fourth year then came the whole business of adding a little bit more in the way of mechanical and civil engineering, mechanical and electrical engineering, I should say. But then the big change did not really occur until 1960, when it was organized that the first 2 years were common and were based purely in the sciences for all students, irrespective of what they were going to do later on. And then they had the option of choosing either civil engineering, mechanical engineering, or electrical engineering, or electronic engineering as it was called. And then there are a vast series of options opened in each of these for them.
So that takes us up almost, Garry, to the time where you started, and maybe we've set the context, I suppose, institutionally into what you were arriving into. Can we now set the context from a personal level? I mean, winding back the clock to those years, what was Garret Lyons, the boy, like, and where did the inspiration to be an engineer come from?
Well, I suppose the short answer to that is nerdy. The other thing was that my father was a watchmaker, and I suppose it was in my genes. I don't know anything better than that. Now, unfortunately, he died when I was 5, and So I've no great experience of the work that he did, but the results lay around me and were quite startling in a vast number of areas. We lived a busy life as children. There were three of us, and it was books for me, books, and more books. And indeed, the lady librarian in our local library would be quite amused by me carting my mother's non-fiction tickets and making up a new excuse pretty nearly every week why I had to go into the adult non-fiction area to get books for her. And it was strange that this woman, my mother was interested in architecture and art and all manner of other things. So that was it. Because of our financial circumstances, I wound up going to a technical school, not that there was anything wrong with them. And in my second year there, I was called by the headmaster, along with another chap, for him to tell us that we were to go to Bolton Street to meet a teacher there whom I can't remember his name. And he gave us some advice on the whole area of the world of work and how to do it properly, and said that we were to go on and meet with somebody in Trinity College in the museum building, as he called it, which we duly did. And I met dear Professor Bill Wright, who interviewed me. I was so terrified. I have no memory whatsoever of any word that he spoke to me at all, other than him being very friendly. The net result of which was that I got a job, first of all declared, I think, as a boy, and this was a waiting period until I had actually sat the vocational certificate, which I gained, and then was transferred to trainee technician in 1961.
And the role that you were being taken on for in 1961 was electronic technician, if I'm not mistaken. And
that's correct. Yes. Yeah.
That's a pretty interesting word in a way, because what may not be so obvious to people listening here is the newness of that as a concept even. So the word electronics only originated in the 1920s or so, and even electronics in a practical sense, the first time computer was used as a word in the digital sense was probably in the 1940s. Transistors were in the 1940s. The MOSFET transistor, the most widely used transistor of all, was only the late 1950s. So you were coming into a very new and very dynamic field. And can you tell us a little bit about what that felt like?
Yes, indeed. Many devices at that stage were still made with thermionic valves. And if you wanted a radio, it was the size of a very large briefcase. And it was a different world altogether. And indeed, the telecommunications that I studied in Kevin Street, its concentration in general was on thermionic valve devices. The transistor, of course, had begun to emerge in funny ways in around about 1947, but in truth didn't become a reality until companies like Mullard and that began manufacturing them in the very late 50s. We had such wonders as the OC71 transistor that was extremely expensive, and everybody started building things with them. We can take, for an example, Akio Morita of Sony, who came into the board and said that he had a vision that people would carry a small electronic device in their pocket, in which would go a small tape recording, recording tape, I should say. And most of the members of the board looked at each other and sort of stuck their tongue in their cheek and wondered, was he going quite balmy? Shortly afterwards, the device was made, and after Philips had done the research work on magnetic tapes, they produced the cassette recorder, and very shortly after that, of course, we went on to a whole vast range of other devices. So it was a very, very dynamic era.
So a very dynamic field into which you were going, and
yes,
we've already hinted in terms of the history of Trinity that there had been a significant change. In 1956, there'd been a move from the 3-year degree to the 4-year degree, but there was another change also happening around the 1960 period in terms, as you said, of choice.
Yes.
Moving from an exclusively civil engineering degree, albeit with some mechanical engineering content, now into an option-led system, more student-focused system, I suppose, that gave students a choice or an option
yes.
to study what I think were called sections at the time, maybe rather than disciplines. Can you tell us a little bit about what it was like arriving in Trinity at that time? And I have three things in mind when I'm pitching that question to you. One is institutionally, in terms of the size and scale and atmosphere of Trinity at the time. Number two, physically, did the east end of campus, did it look very different? I mean, I know it did, but maybe you could tell us in what ways. And thirdly, I suppose, what were you arriving into more locally as a school of engineering? What kind of size was it, and what kind of things were you doing?
If we take the last first, then the engineering school had a staff then of somewhere around about 8, moving to 12 fairly quickly. The number of students in total cannot have been more than 100 to 120. I know there were very odd postgraduate students, very odd numbers of postgraduate students, I should say. The previous was probably true as well. So that was the engineering school. The university, it's the college itself, was much more intimate. People got to know each other very quickly indeed. And even to the extent where after a few years I would meet the provost and he would know me, and we would chat as we walked along. And of course, this was Provost A.J. McConnell. And so it was a very different world in that way. And I think total, I haven't got the, because I'm isolated here at home, I haven't got all the college calendars to consult, but I think total student numbers was somewhere in the region of 2,000.
So a much smaller physical entity. And what about the, what would you have seen walking into the east end of campus? I mean, there was a lot of buildings that are there now, for example, which weren't there. So what did it physically look like? Of
course, the east end of campus was a completely different place altogether. None of the buildings that we sort of know, the Perry, the Nopton Biochemistry building, the Hamilton, the Watts building, there's two others whose name I can't quite recall. None of those were present. Trinity existed only outside its walls for two things. That was the building that I went to, the old Panton's Dental Depot, which became the electronics section in 2021 Lincoln Place, 2122 Lincoln Place, my apologies. And on the other side of college, the north side of college, there was a wall that ran pretty nearly at the back of the engineering workshops, all the way down to where the old Abbey Theatre site was, called Park Lane. And on the other side of that was a set of workshops where the buildings office had their staff. So coming back to the East End, there was a building beside the public house in Lincoln Place. And on that's the side of that then, sandwiched between it and the lovely old Porter's Lodge at Lincoln Place that's gone many, many years, was a laneway that ran down towards the railway line. And on the far side of that laneway was where taking that laneway, and on the other side of that laneway is where all of these buildings were put. So there was nothing there at all. It was a large open space called the parade ground, because it was where the OTC, the officer training cadets in the college in the previous years had mustered and done their drills and so on. So it was a totally empty space. Protruding into it, of course, you had the railway line and also St. Mark's School, which was approximately where the O'Reilly building was, and it stretched inwards. So that is all there was.
So it's a very, very different physical environment.
Utterly different.
What were you doing in those early years work-wise? I mean, how much autonomy were you given? What was the nature of the job? What was happening in the School of Engineering at the time in terms of what your activities and even more generally?
From the point of view of my activities, fairly quickly I moved to Lincoln Place, and there was Brandon Scaife, dear Brandon, who was even at that stage a noted name in the world of theoretical physics and electrical engineering, and the fundamentals of such. Somebody who I would almost say was sort of dropping short of the Nobel Prize. And he had a great belief in people and in leaving people free to work, and that they would do their very best. And so we all did. the place gradually grew. The academic staff there were very small. There was Percy McCormack, who was a physicist, who was there for quite a lengthy period of time. And then shortly after I moved there, Garret Scaife, Brendan's brother, came to fulfill the role in mechanical engineering. Brendan was interested very much in the world of dielectrics and their behavior. And although I was supposed to be an electronics and engineering technician, gradually, due to the research work that was being done, I moved to become more of an instrument maker and designer than anything else. And wound up building equipment for temperature control of the devices that were put into these temperature controlled environments to measure the dielectric properties then of solids. Garret Scaife, when he came, hadn't got a PhD, and Brandon suggested to him that he look into the world of high pressures, so that not only could we have equations of state where you have T as a variable temperature, but we could also have the complete equation of state for matter being its principal property as a function of pressure and temperature. And so we began a connection then with Queen's University in Belfast and the lovely Sir Bernard Crossland, who first of all loaned us some high pressure equipment, and we had the ability to go to, I think in old monies, up to 30,000 PSI, and had a pressure vessel with a very small bore. And Garret Scaife began to have an interest in the properties of liquids. So the next thing to do then was to develop a device that would measure the dielectric constant of liquids under pressure, which of course meant variable volume for the container that held these liquids as they sat inside a pressure vessel, and also the possibility of getting electrical leads out of the pressure vessel so that measurements could be made. And this is a topic that could go on forever in discussion. So it just simply meant then that I began designing high pressure apparatus. We started manufacturing them ourselves within the school, predominantly by me, I have to say, and also then precision devices for the measurement of both liquids and solids. And gradually, I seemed to slide away from the electronics area. And this was particularly easy because there was a chap who replaced the first electronics technician, senior technician, the chap Tony Dunn, who came from Manchester, who was an electronics genius. And he looked after the electronic side of things, and I looked after the rest. That was the environment. And we worked, it was a wonderful place, and it's some of the happiest years I've had anywhere. We worked hard, sometimes 7 days a week, and sometimes we went to the Grafton Cartoon Cinema or to the Chester Beatty Library or somewhere else for an afternoon out. And it was simply expected that you did what was needed of you. And we all cared for each other. It was full of fun and practical jokes. And also, because of Brandon's great reputation, some of the most extraordinary people in the world came there. Father great theoretical physicists, Father Jim McConnell, Herbert Fröhlich, and many others that I can think of. And of course, as well, I can't forget the fact that in 1962, June of 62, came the IBM 1620 computer, but that's another story that goes with John Byrne. So we've got to leave it at that because I could go on forever.
Yeah, I mean, it's clear that was a very enriching personal time in your personal life and your professional life for you. And Garret Scaife is a name that comes up often in our conversations as being a very influential, important figure. And I suppose it was unusual at the time for somebody maybe to evolve. I'm not sure where you were in your in terms of your technical grade at the time. Were you a senior technical officer, chief technical officer at this stage? But for somebody to include you on publications, for example, that wouldn't have been standard, I guess, at the time, would it?
No, it would not have been, and it was very fair of Garret to do so.
So you had moved, as I hinted at in that question, through the grades of technical officer to
Yes,
be, if I'm not mistaken, the youngest ever chief technical officer, chief technician as was at the time.
Yes,
in Trinity. But you made another move then to a different grade of staff, which is the administrative staff. Can you tell us a little bit about how that came about?
The manpower program, although we had the mainframe computer, Brendan Scaife had a very clear vision that graphic computing was something that was going to be most important. And with the monies that were available due to the manpower program, he bought, first of all, the Hewlett Packard 9845 computer. And I was presented with this, with the smiling comment from Brendan of, here you are, smarty pants, see what you can do with that. And so began computing with the particular thing of graphics, which could be seen on the screen and simply printed off onto thermally sensitive paper as well. And this was magical for many people. Brendan would come to me and say, I'm thinking of an equation and I think it does this. And if you just ramble around all the variables and see if you can get a picture that looks like what I've scribbled out for you, I do it. And often I was successful, more often than not I wasn't. And he would tell me that it wasn't my fault, that I was stupid. But we had a wonderful time with it, and it became a device that was used by many of the people in the maths department, Florides, Petros, and several others would come and use the system.
So you mentioned the manpower program, Gary, and I mean that led, if I'm not mistaken, to another significant evolution in engineering in Trinity, which was in 1980. And at this stage, I guess you were in the administrative staff, or maybe just at the end of your role in the technical staff. But can you tell us a little bit about how engineering changed in Trinity in 1980 and what you were doing at that time?
Well, with the onset of the computing, it began to develop more, and I was sort of not drifting away. I kept a fatherly sort of eye on the work in the high pressure area, but the computing zone seemed to take over to a certain amount. And I was then moved to being administrator of the nascent, as it was then, ECAL, Engineering Computer Applications Laboratory. And of course, with the manpower program also came the division of the school into the separate departments of civil engineering, electronic engineering, and mechanical engineering, and then shortly afterwards, mechanical and manufacturing engineering. And we also moved then to what was the pathology building, now the Parsons, and there was a small computing lab set up there, and I went on then computing and offering computing services to all of the academic staff who were there, and to students, final year students and graduate students.
So an expansion, I suppose, then thematically in terms of the different departments and the scale, the number of academics, also the number of students, and you were moving to a new physical home, I guess, albeit not that far from Lincoln Place. But can you tell us a little bit then about your own role and how it evolved? Because shortly after that time, then you transitioned from the administrative staff to the academic staff. Can you tell us about how that happened?
That happened in a sort of a strange way. The first, one of the things that occurred with the split down of the school was that professors of electronic engineering and of mechanical engineering were appointed, neither of whom sadly were either Brendan or Garret Scaife. The man who came to us was Paul Wallace, who came from industry, or the research in industry. A very, very fine man who did not stay very long because he realized the academic world was not his place. And he was followed by Professor David Taplin. And shortly after Taplin came, we held the first Irish Manufacturing Conference. And after that again, then he came to me and said, would I like to do a master's degree in materials? And I said, yes, I would. But the materials that I was the liquid ones that I
appear to have lost your sound, Gary. I don't know if you've pressed a button there or if that's somebody else's done something.
Am I back again?
You are.
So I don't know where I stopped being heard. The chaplain came offering the business of a master's, And after a little some major discussion, he agreed to let me go ahead and look at the world of liquids under high pressure. And I had had a longing for quite a while to take the Tate equation and to add temperature and pressure into it as variables, and then be able to describe the equation of state for these liquids, and embody in that also Maxwell's equations, so that you could then pick out of the fit to this data such things as their compressibility, their temperature coefficient of volume, and a whole range, specific heat, and things like this. This turned out to be quite successful. I don't understand on pompous, but quite successful, and the Masters was awarded.
And when you moved in then to the academic side of things,
Well,
you were handed a portfolio in design. Can you tell us briefly, how did that arise, and how did you, I mean, you had been a very successful practitioner of engineering design, effectively an instrument maker, as you've outlined. But can you tell us a little bit about that period?
Well, I'm not quite sure what year it was, but there was a review by the Institution of Mechanical Engineers and the Institute of Engineers of Ireland, as it was then, and they found that the teaching of design and mechanical engineering was sadly wanting, and inferred, although I don't know the details of this, but inferred that recognition might be withdrawn if this wasn't remedied. So one day, as I'm sitting at the computer, Taplin came along to me and said, Garry, how do you fancy joining the academic staff? I was somewhat surprised at this, but in fact, quite happy to hear it, because where I had been offering and doing very considerable amounts of programming for members of the academic staff, with the ever increasing number of commercial packages that could be bought, I could see that the world of computing in that sense in the mechanical engineering department was going to become more mundane, and so it offered a new excitement, as it were. So yes, I went for it. And
your philosophy of engineering design, and maybe telescoping a little bit here, because this would have been maybe the mid-80s, I guess, where you took over engineering design, and
yes,
then you had another iteration perhaps around 2000 with the engineering management course, where
yes,
you had a blank canvas, I guess, to put into practice.
Had to look at the date there. Yeah, 1987 I actually began, and from the point of view of how I went about it, I looked very carefully at how I went about it myself, as I created objects that I had done, and also to see what in the world was going on in education in terms of teaching design. And the thing that I found was the VDI 2221 and VDI 2222, the Verein Deutsche Ingenieur guidance for engineering design. And then came upon it, it had only just been published, if I recall correctly, a book by Pal and Beitz on engineering design. And as I turned the pages, it was almost as though I'd written it myself. And I thought, if they go for it, and if so many other, like Kesselring and so many other noted engineering designers in Germany had gone for it, yes, this was the way. And my belief was that for the engineering students, we weren't attempting to turn out engineering designers as such, because their knowledge of production capabilities of machinery and things of this nature would not have allowed them to actually practice fully. And that what we needed to do for a generalized, relatively short, it was only 1 year, third year that it was taught in, for a short course, the thing to do was to give them an understanding of the methodology of design and some flavor of how to go about it and the problems that one confronted. And most importantly of all, and as I used to say to them, just when you think you're God, you find out you're an idiot. And I had learned this so often myself, and to know that feedback, the feedback loop going back and to the previous step and thinking again. And that this was the crucial thing for them to learn. And one of the good things about the VDI system was that it embodied all of these paths. And so I proceeded with that.
So maybe I'd like to kind of take us forward now from your experience as an educator and looking forward maybe into what the Provost referenced, which is the E3 project. And as a segue into that, I suppose I'd like you to ask you to reflect briefly on the nature of where design sits in engineering education and what lessons you may have learned from your work as a designer and also from your education, because you have the scientific content that underpins the work of an engineer, and that's given mainly in the earlier years, and then you have design, which can be seen in many different ways as a unit or component skill, or it can be seen as an integrator, or it's also a creative outlet. So a very broad question, I realize, but when you reflect on your 60 or so years association with Trinity and with design in engineering education in Trinity, are there any fundamental truisms that you would observe, any major lessons that you've learned, any things that you think are really critical to engineering education and design particularly, and what lessons might they have for E3, for example?
Well, I think, to my mind anyway, there is a simple truth, and that is that engineers prostitute science through technology to make useful things for the human world. And in order to do this, at the heart of their education must be the fundamental areas of science, physics, mechanics, and so on. And without these, they fail, because as the years go by, when things change, they simply won't be able to refresh or renew themselves. So that's one thing. And thinking about it takes you directly to E3. I only wish I had a little key that I could put in and wind around and turn myself back to being about 30, because I would love to be there with E3. I think it's a wonderful opportunity, and it's where engineering is going. When you think about it, the Romans built viaducts to bring clean water into the people. Joseph Bazalgette created the great sewers in London to get rid of the great stink and the typhus that was killing people in large numbers. So human engineers doing good things for their human friends has always been true. And I think it will become ever more so with the whole E3 approach.
And what excites you particularly about E3? Is it the impact? Is it the challenge-based nature? Is it multidisciplinarity? Is it a project style focus to engineering? Are there any particular dimensions that you find fascinating with you?
I think predominantly it's the fact that the engineer will have a vast impact for good on the earth if this is gone about in the correct way. And I think that's the most exciting thing about it. Now, how that will happen is anybody's guess. We don't know what materials we will create and how we will then understand how to embody them into the engineering devices that we make. We have great needs then to look at the whole world of engineering ethics and embody an understanding of the E3 world into it, the environment, better environment into it, and also into engineering standards. And all these are at the heart of engineering design.
Garry, entertaining as it is and fascinating as it is, we could continue this particular line of discussion, I'm sure, all night. But normally the reason we're here is to mark the completion of your second book. And obviously, being a second book, there was a first, and the first of the Provost, as talked about, was the history of the Kingstown Railway. So you came to be an author in terms of books as opposed to papers and manuscripts and so on later in life. Your second book is on the great exhibitions, which I think you would probably feel is a neglected or forgotten piece of Irish history. Can you tell us a little bit about what motivated you to write this particular book?
Well, two things. The first, as you say, because they're virtually forgotten about, and I would hazard that 80% of the population of Dublin or Cork couldn't point at where they actually occurred at all. The other thing was that looking at the generalized history books for the 19th century, they have this monocular view of the troubles of the 19th century and the great battles and the Fenians and the Young Irelanders. And of course, there was another side to life of social history and economic history and so on, and probably best tackled as a book by somebody with the same name as me, FSL Lyons, one of our provosts, who wrote Ireland After the Famine, a magnificent piece of work. And I thought, well, it's been so long away, it's written that it's probably forgotten about. And here, can I produce a book that is written for the general reader, like our provost said about the railway book, that contains the brilliant engineering, the engineers, the philanthropists, and the social thinkers who gave a bright light, as I say at the end of the book, into a dreadfully gloomy period, 1850 to 1900 and all. That was the push to do so.
So to wrap it up then, Garry, and referencing maybe some conversations we've had on the topic before, there was multiple motivations for having these great exhibitions. As you've hinted at, there was philanthropic elements, but also maybe the context is important to kind of reflect on a little bit here. With the first exhibitions we're talking about here in the early 1850s, so we're literally just after the famine. The country has been decimated, is on its knees, physically, but also I suppose emotionally and mentally, psychologically. The role, I'd like you just to say a couple of words about of the exhibitions in terms of bringing information to people and why that was important at the time. You know, what was the context here? You know, radio, television, you know, internet, rail travel, car travel, for example. All of these things were either not there or in the relatively early stages. So why did the great exhibitions, why were they so important?
They were so important because they allowed people to actually view what was being manufactured in your area or your country, and also to see the developments. And if you had international exhibitions, to look at a particular device, we'd say maybe a cloth, and look at how it was made in France or in England or in Austria, depending on who came to the international exhibitions, and to gain some idea of the quality and level of manufacturers within your own country or your own area. And that this would be a help not only to the wealthy manufacturers, but also to the artisans who made it. And one of the things that the exhibitions did was they pushed to develop artisan education, and in the end succeeded in this very well, strangely enough, by an often unknown exhibition in 1885, the Irish Artisans exhibition, which was run to a large extent by artisan people. And out of it, the great Arno Graves pushed and eventually caused the foundation of the technical schools, Kevin Street, and next of all, technical school in Pembroke, with argument from the Earl of Pembroke. And out of that grew the institutes of education for technical education throughout the country, with the help of Horace Plunkett. And then eventually the colleges of technology, and quite lately, the Technical University of Dublin, which, interestingly enough, as Arno Graves was a Trinity graduate, is now led by David Fitzpatrick, another Trinity graduate. So the circle closes.
Garry, thank you very much for that fascinating overview and for wrapping up, I guess, there on the impact of tonight's topic on the great exhibitions and how impactful they were, I suppose, in terms of lifting the morale, but also the lasting legacy, as you've just said, in terms of education and infrastructure. So thank you once again. I hope everybody in the audience found that as interesting as I did, and I hand back to Garret for the next stage of the evening.
Okay, so Kevin and Garry, thank you very much for that perspective. And Kevin, thank you for helping Garry to get through that. You can see, colleagues online, how we really enjoy when Gary's around here with us in Trinity. You know, when he's joining us at the coffee and when he was preparing his book, we really enjoyed that. time with him and the discussions. So we have a number of people who, I mean, you can see that Gary's around a while. So we have a number of people, you know, whose life Garry had an impact on, either supporting them in the design of their experimental rigs, or an impact as a student, or an impact as a colleague. So I'm going to just invite one or two people forward and just navigate our way through this, just to make a contribution to the evening. So the first that I'm inviting forward to unmute is Professor Kiron Sims, and Professor Sims and Kiron is the current head of department here, and he was the first of Gary's PhD students. So Kiron, if you'd like to unmute and maybe just come into the conversation.
Sure. Hello, Garry.
Hello, Kiron. Good to see you.
And you. Well, it's a real pleasure for me to be able to talk to you in this setting. I'm here in large part because of you. You were my mentor. I graduated from mechanical engineering in 1995. Hadn't realized how late in your career that was at the time. And then I enrolled as a research student with you under your guidance. And in third year, I recall doing a course with you on design. And we had a group project to design a device to measure tension in a cable. I don't think I did so well in that project, but I remember your lecturing style and its positive effect on me. Your lectures, they engaged me so much that I wanted to be part of what you were doing. And the following year, I got a chance to work with you on injury biomechanics. We did a project on whiplash. And I'm still, 25 years later, largely consumed with injury biomechanics. It's defined my whole professional life. So, you know, your lecturing style, it had certain idiosyncrasies. You liked words like serendipity, which we had to go and look up. Serendipity functions, I remember. But you've been hugely beneficial to me. As a student, you made acres of time to talk to me as I skilled up slowly in various areas. You taught me a love of learning, and your strongly ethical approach of treating people well left an impression on me. And most of all, I think the power of approaching teaching in an engaging manner, which I've tried to copy. We also enjoyed a good laugh together, not least when we were mistakenly checked into a single room in a London hotel in the mid-90s. To me, Garry, you're timeless. When I was an undergraduate student in 1994, I thought you were ancient, and now you seem to have become younger. And I wish you all the best.
And thank you, Kiron. And it's a pleasure to know you, and it was a pleasure to have you as an undergraduate and as a postgraduate student. It really was.
Very good. Okay, so Kiron, thank you very much for that contribution. That was lovely contribution and input to make there. So the second person I'd like to invite into the conversation here is a graduate from 1980s X, maybe we could say. That's Professor David Fitzpatrick, who's the president of Technical University Dublin, the first technical university on the island of Ireland. And Garry has spoken to that occasionally as he was going through the contributions that institution in its former life has made to the Irish educational system. So David, if you would like to unmute your microphone and maybe come into the conversation. Of course, we know you also as a hardcore engineer and design advocate.
Thank you very much, Garret. Hi, Garry. How are you? Good to see you.
Good to see you.
And thank you for the mention of that other institution in the Dublin city centre region. So I appreciate that. You know, I didn't realize I was at the cutting edge of computing and mechanical engineering. I mean, I'm a 1985 grad, so from your fireside chat, really kicking off that in terms of your role.
Well, the graphic computing was quite an innovation, but of course we have to remember John Byrne and his computer, which came to us in 1962 and developed from there. One of the greats of Irish history in the world of engineering.
Yeah. Well, you know, I know in my particularly third and final year, spending time in the design office and talking with you and my other fellow students as well, talking about design, about computing and things we could do. And I think your guidance was very valuable. I don't know whether there was subliminal messaging around design process and design methodology. I don't remember the formal side so much, but you know, I think it's no accident I ended up in a design role in R&D in the orthopedic industry and really benefited from that. And I think since then, of course, coming back to Dublin, working with the section of bioengineering that the provost mentioned, the RAMI subsection where we had the design forum and met with the surgeons, which that was actually a unique.
Yes, indeed.
And I see Clive Lee is on the call as well. I think bringing together surgeons and engineers to have open forum discussions around problems that can be addressed and solutions found. I think your approach was always very much the problem solving. What are the solutions? How can we have some creative ideas and creative thinking around it? And I think you added to those conversations greatly. So thank you for those. And maybe that's an entity we should bring back into a more structured form.
Thank you, David.
Yeah, I just one thing I'll close. You mentioned Arnold Graves and his role in establishing technical schools in Dublin. I think in the 1870s, in making the case for those institutions, the quote I love most is the fact that he stated that Dublin is ripe for technical education. I think we can arguably say it is absolutely still ripe for technical education. So I think E3 and the other innovations that are coming down the track in Dublin are going to be really, really significant. So thanks again.
Indeed, and thank you, David.
So thank you very much, Professor Fitzpatrick, for that contribution as well. I mean, it's really also heartfelt and clearly clear to see, Garry, how much esteem you're held in. So we had maybe two other people that just weren't sure if they would make it on the night, and they put forward a video, a pre-recorded video. So we have Professor Conor Walsh, who's the Paul A. Meader Professor of Engineering and Applied Sciences in Harvard. He was one of your project students, Garry, you'll remember. And then we have Professor Fergal O'Brien, Director of Research and Professor of Tissue Engineering and Regenerative Medicine in RCSI. So both, again, who hold you in high esteem, and they just have a little video here that we'd like to play on your behalf, that should just run for us now, I'm hoping.
Hi, Garry. It's Conor. Long time.
Hello, Conor. Good to see you.
On this special day. I always remember taking your junior design course in Parsons, and that was really my first exposure to mechanical design. And I was definitely a bit overwhelmed by all the material, and in particular there was no one right answer to many of the questions, and that was the first time I really came across that. But it definitely kind of really inspired my interest in getting involved in that field. And then as well, I definitely deeply appreciated all the time you spent in many of our meetings during my final year project. I'm sure that I showed up in your office too many times and too often, but I left every meeting feeling more enthusiastic than going into the meeting, so that's great. And I definitely credit that experience with kind of guiding me on a path for a research career. So thanks so much for that. And then, congrats on your great career. I can only aspire to, hopefully now have, as much success as you in mentoring other people in engineering design. And congrats on the new book. That's very exciting, and I'll have to get my hands on a copy. All the best, Garry, and hope you're well.
So thank you very much for the opportunity to talk here this evening and to give you my perspective on working with Garret Lyons over the years. I'm Professor of Bioengineering and Regenerative Medicine and Director of Research and Innovation in RCSI. And I've had a very long evolution, I suppose, in my career. And some of this was very much influenced by Garry. And I first met Garry when I was a confused third-year engineering student in Trinity. And really, I was trying to figure out why I was doing this course and why was engineering the right course for me at all. And it was Garry's design course and his infectious enthusiasm that really began to first show me the possibilities. And I then subsequently got to know his biomechanics work. And that really was probably my first exposure to the field of biomedical engineering. And after I was offered a PhD by Clive Lee and David Taylor, I went to chat to Garry really to get his perspective on it and to see what did he think was the right way forward for, again, a confused engineer. And of course, he was very enthusiastic, very supportive, and gave me a lot of his perspective on it. And that was really the start, I suppose, of my own career. That evolution over the years then I've met Garry in all sorts of places, chatted to him regularly, especially at Bioengineering in Ireland conferences. And I have to say, I have to owe him so much, and his mentorship and guidance for so many students and young faculty over the years has been so critically important to their development. And Garry, on a personal level, I thank you sincerely. I hope you have a great evening, and I really look forward to reading the book as well too. So thank you.
So another two very nice contributions, Garry, I think there into the thing, and for you. So maybe just the last of the contributions here, just in this part of the meeting here, I'm going to ask Professor Henry Rice, your long-standing colleague and friend, maybe to give us a few final words on this part of the meeting. So Henry, if you'd like to unmute and maybe come into the conversation.
Thanks, Garret, and thanks Kevin as well, and indeed Paddy for a great hosting of the event. And Garry, we could listen to you as we have done for many years, tell us all of these stories that are important to our heritage. I think one of the things that I'm particularly proud of, and it's an evolution of where you've come from, is the firm establishment now of the 5-year program, which really only kicked off in 2012. But going back into the day, I would personally like to thank you for welcoming me into the school as it was. I joined in 1985, and we, I suppose, had differences on computing at the time, as you know, you were wedded to the HP, and there were things like PCs turning up, and we weren't always quite sure, you know, whether these things were to be trusted or not. But you know, you have left us some permanent concepts in the lore. For instance, the word ecal is something you created, and we still abide by that. And ecal, the name has survived, even though it has had different locations. I think it's been in 3 different locations at this stage. And another interesting thing that many might know is that you had a computer named after you, which we called Leo in firm reverence, of course, and very appropriate towards that. And this was a Unix-based computer, and it was a fabulous machine. And I think you're referring there to the advent of the finite element software that just arrived at that time I suppose in the early 90s. And we happily used this innocently as we did at the time. And I think you were nodding wisely on the stage when we discovered that this was the first victim of an attack, a virus attack that we had experienced when I think a lot of French people were using it to sell football jerseys or something at our expense. So we, at that stage, we had an open network. Everything was free. You could, there was no restrictions, no security on the net. Yeah. And it was a very exciting time. And I suppose now things have got a lot more complicated. And then later, of course, we moved on, and I think as I ended up being dragged further and further into administration, I'd also like to thank you for the welcome you always give to me. Quiet welcome in your room when I might have had to vent off after some discussions I was just fresh from in the coffee room, and other matters that were on at the time. So that's it, Garry. It's great to hear from you, and great to see you looking so well. And congratulations on the books, on both books, in fact. And I really enjoyed reading the Sucking Up to Dalkey book, and I walked that part of the land on many occasions, and we can pick out the features that you've had in that book. Thanks.
Okay, so thank you very much, Henry, for that contribution. So again, Garry, I think there's a lot of warmth also coming through on the chat here for you and for your career and the person you are. Without putting you on the spot, Garry, we're just going to ask if you invite you to maybe make a final remark or a comment, Garry, if you would, or if you'd like to, or if you don't, we can move. So would you like to say anything, Garry, just before we move to the next part there?
Well, just very briefly, I'm humbled and embarrassed by all the comments that have been made. And one thing that I'm sorry about is that dear John Fitzpatrick isn't here at the same time as us. That's it.
Yeah, indeed, Garry, thank you for that. And indeed, we remember the colleagues, Professor Fitzpatrick and John Monaghan, some great colleagues from former times as well, who really shaped engineering. So what we'll do now is, what we've said is that, if you like, kind of finishes out on our more formal part of the evening, if we could call it that.